Welcome to a video lecture on the biosphere by me, Mr. DeBacco. You may remember me from such films as the Ecological Organization, because this video lecture picks up right where that one left off with the biosphere. So this slide may look familiar if you watched that previous video lecture, but let's start here with the biosphere. It's all the biomes together with marine and fresh water included. The Earth has 4 major connected systems, which we are going to go over in detail here. The atmosphere, the ecosphere, the hydrosphere, and lithosphere all coming together to form the biosphere, which is a portion of Earth that's inhabited by life, including all biotic and abiotic parts. So starting with the hydrosphere, all of Earth's water, ice, and water vapor is all included in the hydrosphere. Oceans account for about 96.5% of the water, but that is salt water, and it's found in the oceans. Freshwater is the remaining 3%, and that may be locked up in glaciers and ice caps, or in groundwater, or surface and other freshwater. This surface and other freshwater is mainly the accessible component that we have, and most of that is composed of ground ice, or permafrost, or lakes here. The freshwater distribution, as you can notice here, it's a very limiting resource. Ice is about 1.762%, groundwater is the next most abundant, and surface freshwater, you can see, is a very small percentage of the total hydrosphere. Atmosphere and soil is even a smaller percentage than that. This is why the world's so concerned with not only the amount of water we have, but really the amount of fresh water we have access to, because the vast majority is locked up in oceans, which is salt water, which is not really usable for both human consumption and also to grow plants. The oceans and ice, what bodies of water hold the largest amount of water? Well, it's the oceans. They are our largest bodies of water on Earth. However, they contain salt water only. You see all the major oceans here, the Arctic at the top, Atlantic, Pacific, we have our Indian Ocean here. So we have all of these areas, but they're very large, but however, this is all salt water, not really usable in most forms by a lot of our terrestrial-based life forms. Moving on, we have oceans and ice. So icebergs, they're large pieces of fresh water or ice flowing in open waters. About 90% of icebergs is below the surface of the water. So it comes back to the Titanic here, and Sally ran into an iceberg. A very small portion of the total iceberg is actually exposed above the water that can be seen. The vast majority is located beneath the water surface, which makes them very dangerous for traveling boats. Continuing with that ice, we also have glaciers, and there are any large mass of ice that moves slowly over land. Sadly, we're seeing a lot of the glaciers that are being reduced. You could see the evidence of where the glacier line was here in 1985, and this picture was taken in 2003, how much it's receded. Again, images of the same area taken in different years, and we can see the great receding, or sadly melting, of these glaciers. The freshwater locations is surface water. So what's the difference between a watershed and a river basin? Well, both terms are used to describe land that drains into a river, stream, or lake. However, a river basin is the term used to describe an area that drains into a large river. The watershed is the term used to describe the area that drains into a smaller river or stream. So you can see evidence here of the Connecticut River and where the river basin is. Remember, that's the term that describes drains into the large river. And then the watershed is a term used to describe it drains into smaller river or stream. So this kind of be a general overview of the watershed of the Connecticut River, and the river basins would kind of be closer to that large or main river there. So I have something called groundwater. So what's groundwater? Well, simply put, it's water that's below the ground. The water found in cracks and pores in sand, gravel, and rocks below the Earth's surface. Now, below could be just a shallow area here, or it could be deep below. Now, it takes a lot of or more time for water to penetrate and get down into the deeper layers, but all of this is considered groundwater. Whether it takes only a couple days to get below the surface, years, centuries, or millennia, it is all considered or falls in the category of groundwater. We have something called aquifers. So it's a rock layer that stores water and allows water to flow through it. Aquifers are kind of like these large almost underground lakes that occur, and a lot of them can take a very long time to recharge for water to get in there if we do pull some out, but they're typically very large areas. We have wetlands, an area where water table is at, near, or above the land surface long enough during the year to support adapted plant growth. So a wetland is an area here we see where that water table is at, near, or above the surface. It does contain water for an extended period of time. Some wetlands can dry up over time, but some will hold water. The key part there, long enough during the year to support adapted plant growth. Additional hydrosphere vocabulary, we have a tributary, which is a stream feeding the larger stream or lake. A tributary is contributing that water, and they can flood during times of heavy rainfall. Reservoir is a lake that stores water for human use, and an artesian well is a well in which water rises because of the pressure within the aquifer. So we see an example here of the artesian well. If the saturation level is above, we punch a hole here, a lot of pressure, kind of the water flowing down here. You can get this kind of free flowing, this natural flowing of water through an artesian well. Third, we have the atmosphere. So again, we're looking at this biosphere in general, looking at the atmosphere. It's the air blanketing Earth's solid and liquid surface. So when we take a breath in, the amount of air around us here is mostly composed of nitrogen. It's the most abundant gas in the Earth's atmosphere, making up about 78% of the air that you're breathing here on Earth. Oxygen is the second most abundant, making up 21%. And living organisms are used as food sources, and oxygen is utilized by organisms that digest other organisms. Oxygen is released in the atmosphere by plants as they photosynthesize. Earth's atmosphere has a unique composition of gases when compared to other planets within the solar system. The blue light is scattered more than other wavelengths by gases in the atmosphere, and that is in part what gives the blue color to the sky. Now keep in mind that there is carbon dioxide, there is neon, there's helium, there's hydrogen, but we could see these percentages down here are a lot smaller. Nitrogen by far, looking up here, is by far the vast majority at 78%. Then comes oxygen, a little argon. We see this kind of thin sliver here. Carbon dioxide is the vast majority of this small portion at 0.0407% or 400 parts per million. We can see the others are much smaller, but they do exist. This composition of the atmosphere, looking specifically at carbon dioxide, makes up approximately 0.03% of the Earth's atmospheric gases, and it changes a little bit depending where you are, and it's also sadly changing over time. So carbon dioxide concentrations in the atmosphere are regulated by the removal of carbon dioxide from the atmosphere by plants as they fix the carbon from carbon dioxide into carbohydrates, and exchanges of carbon dioxide between the atmosphere and the oceans. There's also chemical reactions that occur between the atmosphere and limestone. We're kind of seeing that concentration of carbon dioxide increase very dramatically over recent years. In the atmosphere, we have water, which is the atmosphere's varies considerably and also contains the hydraulic cycle. This cycle is the evaporation and condensation that results almost daily here. We see kind of that water cycle here. We're having evaporation of water, that condensing of water, that precipitation, and that kind of water cycle repeating there. In the atmosphere, we have atmospheric pressure, and this is the pressure that the atmosphere exists on Earth, and it decreases with increasing latitude. So if you seal a bottle up at a very, very high mountain peak, when we start walking down that mountain, and we're probably driving, more realistically driving down that mountain, you can see it getting crushed here, because this volume of air contains less particles than it does at sea level. The greater the altitude, the same volume contains fewer molecules of gases that make up the air. This means that the density of air decreases as you increase in altitude. If you're at the very top of a very, very tall mountain, there will be less dense air than if you're at sea level. Atmospheric pressure versus altitude, as we can see here. The atmospheric pressure, see more density down here at the very bottom than at the top of a mountain, for example. This is a mountain very high. Denver, for example, would be mile high. It's 5,280 feet above sea level, but there's mountains much, much higher than that. Fourth component of the biosphere is the geosphere, and this features Earth's surface, kinds of rocks, the seafloor, and everything below the Earth's surface. It's made up of rocks, and rocks are made up of minerals. These minerals are building blocks for the rocks, and elements are the ultimate building blocks for those minerals. We see that example here of forms of carbon. We have amorphous carbon, which is kind of this blackish kind of substance here. We have graphite, which is carbon organized into sheets. And then we have diamonds, which is carbon organized in a very particular structure there. The geosphere is made up of rocks and minerals. Just 8 elements account for about 98% of the Earth's mass. Elements composed of the Earth's crust, as we can see here, oxygen and silicon, kind of by weight, a very large percentage. But there's also aluminum, iron, calcium, sodium, potassium, magnesium, and a host of others. Looking at the formation of the geosphere, these are the formation of elements by the collision of the sun. It's released as heat, and it's changed from kinetic energy to heat energy. The more gravitational attraction towards planet Earth's center. This also can lead to radioactive decay, and we see that here with the formation of our geosphere. That's caused by the collision with the sun. It's a very, very large scale. And keep in mind, this is not exactly to scale here. Last, we have the layers of the Earth. We have that inner core, which is actually a solid, surrounded by the outer core, which is liquid, and we have the mantle here, ultimately leading to the very edges here, where we have the Earth's crust here. And basically, that is the area that life as we know it exists, and we build from there. The inner part of the Earth is extremely hot here. It's the inner core here being a solid, the outer core being that liquid component of basically melted iron.